Hello, Dr. Castellana here, and in this video we will be discussing variation. So with direct variation, we say that y varies directly with x, or y is directly proportional to x, if there exists some constant k such that y equals kx, or k times x. The constant k is referred to as the constant of proportionality. So let's do an example of direct variation. Suppose that y varies directly as x, and that y equals 21 when x equals 4. What will y equal when x is equal to 10? So the first step will be to find the variation equation, which basically means we need to figure out what k is. So we're going to start with the variation equation in its most basic form, y equals kx, and we will use the given values of x and y to determine k. So plugging in x and y, we get 21 is equal to k times 4. Dividing both sides by 4, we get that k is 5.25. Then we use this value of k in the equation along with the desired x value to find the desired y value. So we get y is equal to 5.25 times 10, which results in y being equal to 52.5. So under this current relationship, if x is 10, y will be 52.5. Another type of variation is inverse variation. We say y varies inversely with x, or y is inversely proportional to x, if there exists some constant k such that y is equal to k over x. So instead of being multiplied, we're now dealing with a division. One thing to note, with direct variation, if x got bigger, y would get bigger. And if x got smaller, y would get smaller. With inverse variation, they're going to go in the opposite directions. So as you make x bigger, this fraction over here, as its denominator gets bigger, its value gets smaller. So as x gets bigger, y gets smaller. And as x gets smaller, if you make the denominator smaller, y will get bigger. Again, the constant k is referred to as the constant of proportionality. All right, so let's look at an example of inverse variation. Suppose that y varies inversely as x, and that y equals 2 when x equals 8. What will y equal when x equals 5? Now, if we go by what we did before, going from 8 to 5, we're making x smaller. So since this is inverse variation, we should expect that y will get bigger. We're going to use the same exact process that we did with the previous example, except instead of using the direct variation equation format, we're going to use the inverse variation format. So we start with the variation equation, y equals k over x, and we will use the given values, again, the given values we had of x and y being 2 and x being 8 to find k. So when we go ahead and plug those in, we get 2 is equal to k divided by 8. Multiplying both sides by 8 gives me that k is equal to 16. And now I'm going to take this k value and plug it back into this variation equation and use that along with the x value of 5 to find the desired y value. So when I plug those in, I get y is equal to 16 over 5, and that simplifies to y being equal to 3.2. So under this relationship, when x is 5, y will be equal to 3.2, which is actually bigger than 2, so it did do what we expected. Now, sometimes you have more than just a pair of variables, and they're related in a combined way. When there are more than two variables that are related, we use what's called combined variation. When a group of variables are related through direct variation, it is often referred to as joint variation. So we might say that y varies jointly with x and z. In that case, we would have y equals k times x times z. It is also possible to have a group where some of the variables are related directly and some are inversely. For example, Newton's law of universal gravitation states that the gravitational force between two objects is jointly proportional to their masses and inversely proportional to the square of the distance between their centers. So we're saying the force of attraction between the two objects is jointly proportional to the product of their masses, and at the same time, it's inversely proportional to the square of the distance between their centers. So if we want to turn this into a variation equation, we get that the force is equal to K times mass 1 times mass 2 all over the square of the distance. All right, so in the numerator up here, we have the joint variation going on. We've got the product of the two masses, which is going to be multiplied by the constant of proportionality K. And then in the denominator is the square of the distance, because that's the thing that's inversely proportional. So we put that all together, and this is now a relationship that relates all four variables: the force of attraction, the two various masses, and the distance between them. Now, in physics, they've actually determined what this constant K is for Newton's law here. Off the top of my head, I don't know what it is, but it's the gravitational constant. All right, that is the video on variation. I hope you enjoyed it.